Jeez, that's bright. Hi, I'm going to be mounting this 100 watt equivalent LED chip that I got off Amazon on my quadcopter here. The data sheet says it runs off 28 to 35 volts and can pull around 2.4 amps. It says it can go to around 7,000 lumen or 8,000 lumens or something like that, which is complete and total BS. And the 100 watts is all equivalent. Basically, it's no more than like a 10 watt bulb here. But anyway, I mounted the chip onto a heatsink, and I want to be able to put it on my quadcopter. So there's three main design considerations when we're doing this. The first of which is how we're going to mount it to the quadcopter. We're going to need some larger landing gear. The second of which is how we're going to switch it on and off in midair off of a PWM channel on my RC receiver. And the third consideration is how we're going to power it. It doesn't draw too many amps, but keep in mind getting 28 to 35 volts can be a little bit tricky on a quadcopter when there's only a 12 volt battery. I mounted the quadcopter onto the longer landing gear. It kind of looks silly, but it'll work fine. I just used some Velcro, some really nice Velcro with good adhesive on both sides, and that's good enough. I'm not going to leave this on here permanently. I just want to do this because it's going to be pretty cool. Now I have to mount the LED. So I have this little handle on it just because I was using the LED before. So I'm going to pop the handle off, and then we're going to find a way to mount this underneath it, but we're also going to have to plan ahead because we're going to have to put a secondary battery pack on this to power it. So I'm probably going to mount the battery pack just underneath the center of gravity, which is right here. So it's going to be set back a little bit, because as is right now, with the GoPro on the front and with the battery right here, it's perfectly balanced, so I don't want to upset that. So I'm going to put the battery perfectly under the center of gravity, maybe a little bit back of it, so I can put my lens, LED, and heatsink assembly a little bit forward of the center of gravity, and it shouldn't affect that too much. I mounted up the LED and heatsink and lens assembly underneath the quadcopter to the landing gear with a couple of zip ties. It's pretty simple mounting, but it's fairly sturdy, and it also offers a little bit of vibration dampening, so that's kind of cool. And I don't think any of this is going anywhere. It's going to be sturdy enough. Next is to figure out how we're powering this and controlling it. So for the battery, I just built a 8-cell lithium-ion pack out of 18650s, and that's charging up right now, so we'll have that in a few minutes. And while that's charging, we'll go ahead and make the control circuit, and I'll show you how I'm using a MOSFET to drive this off a PWM signal. So that we can control the LED in midair, I grabbed us a MOSFET. This is an N-channel MOSFET. It's an FQP30N06L made by Fairchild Semiconductor. I bought this from SparkFun. We can control up to 60 volts and 32 amps constant, and that's with a heatsink. So basically that means that we don't need a heatsink when we're driving our load of about 30 volts and 2 amps, so that's no problem. I have the schematic up on my computer right here, and it's telling us that the pins are labeled gate drain source from left to right, so that's pretty much standard. Looking through this some more, yeah, 60 volt drain source voltage, so we're totally fine running this at 30 or 35 volts. So I want to find the gate trigger voltage, or threshold voltage rather. Yeah, so gate threshold voltage minimum 1 volt, maximum 2.5 volts. So that's no problem. We can run this off of the 5 volt logic levels of the quadcopter. Going back to the paper here. So the pins are labeled gate, drain, source from left to right here. And the standard way of drawing this in a circuit diagram for a MOSFET is circle, the gate is out here, and drain and source. So when we wire this in to the quadcopter, attached to the gate needs to be our 1 to 2.5 volt input, and this is like the trigger. So the trigger of this MOSFET that turns on and off is voltage, rather than say a BJT or a transistor, which is current controlled. MOSFETs are voltage controlled. So we apply voltage between the gate and the source, and that closes the path, or it closes the circuit, allowing electricity to flow from drain to source. And the drain source specifications, as we read in the data sheet, were 32 amps at 60 volts. So we're going to be attaching the gate as the positive from our PWM signal, and the source as a negative from the PWM signal, and then the drain as the output to the negative output to the LED, and then the source is also going to be attached to the negative of the battery. And then the positive is always going to be connected from the positive of the battery to the positive of the LED. So this is an N-channel MOSFET, and we're switching the negative wire on and off between the LED and the battery. And so that we can use our RC controller here, I set up a channel in here, channel 7, to potentiometer number 3, and I'm testing that just with the servo here. And that's outputting a PWM signal, and we're going to drive our MOSFET off of that 5-volt signal. Okay, now for a really clever part. I wired up the MOSFET like we talked about earlier, so we have the voltage coming in from the battery, and it's being switched on and off. The problem is, if we connect the MOSFET directly to a PWM signal, then the light that we see coming out of the LED will appear very flickering, and we won't have full control over it because the PWM values coming out of my receiver aren't the full range of, say, 0 to 1,000. I'm only getting a portion of that range, and no matter how much I play with my radio, I can't get the full range, so we'll never hit full brightness on the LED. So what I decided to do was take a Turnigy 9-gram Hextronic servo. They're really cheap, and I popped the top part off and took out all of the gears on it. So now I'm just left with the servo itself, and I'll zoom in to give you a little bit better look, but we're basically making a PWM to standard voltage converter. So when this receives a certain PWM signal, it outputs a voltage. Here's the servo I was just talking about. So what you want to do is you want to assign the servo to a switch on your controller. I have it set up right here. And you'll notice there are 2 shafts coming out of the top of the servo. The first one is the motor. The second one is a potentiometer shaft that provides the microcontroller in here with feedback when the whole gear system starts to spin, so the servo itself knows what angle it is at. So when this potentiometer is not connected to the motor here, if it's in a random position, it'll spin indefinitely because it's trying to get to, say, 60 degrees or 75 degrees or some number, but it will never get there. So what you want to do is you flip the switch on your transmitter to the position that you want to be off for the LED, and then you adjust the potentiometer until it's off. And then now, when you flip it to on, it'll try to go to a different, because right now it thinks it's at a certain angle. And then once you flip the switch, it'll want to go to a different angle. And it'll never get there because the potentiometer never moves. So now, that's perfect. So all we have to do now is open up the servo and take the 2 wires going to the motor itself, and we're going to hook that up to the MOSFET. We're going to need a resistor most likely, unless the voltage is absolutely perfect, but that's how we're going to drive the MOSFET off of a PWM signal. I cracked the bottom part of the servo open, so right now I'm going to measure the voltage that this little controller board is outputting to the motor. So you can see how much of a resistor we need to make this be capable of driving our MOSFET without getting past that threshold voltage. So I'm just popping the 2 protruding shafts out of the case. So like I said, one's the motor, one's the potentiometer. Okay. Pretty cheap potentiometer. Yep. And that's that. So hook it up to my receiver, and we're out of adjustment. So this is just going to spin and spin and spin. So I'll put it back into adjustment. Now when I flip my switch, nothing happens. Okay, it looks like our potentiometer shaft is all bent. So what's up here? Well, what you saw was working a minute ago is no longer working. Okay, I fixed it. The potentiometer shaft actually bent a little bit. I'm shorting out some contacts underneath it. But now, when I flip the switch on my transmitter, the motor begins to spin, and I can change the RPM of the motor by adjusting the potentiometer. So I'm going to see the output voltage from this board, and I'm going to adjust the potentiometer until it's exactly what I want to drive my MOSFET. And then I won't need any kind of current limiting resistor or anything. And that's pretty awesome because we can just hook that straight up to the MOSFET, mount everything up, hook up the battery, and we are done. So multimeter right here. 0.5 volt right now. So we want a little bit more speed than that. 3.6. A little higher. Yeah, so I guess that'll be fine. 2.4 should work for us. What I'm going to do now is cut off the little motor from the PCB here and attach the MOSFET gate and source to that. Oh, now I got a little vibrator motor for like a cell phone or something. Cool. I hooked up the output of that servo board to the MOSFET, and as you can see, when I flip this switch right here on my radio, the LED comes on and on and off. And right now I'm just powering this off my bench power supply at around 28 volts, so this is nowhere near, actually like 25 volts, and so this is nowhere near the actual full brightness of that. And I don't know if you can see in the camera, but the light that it's emitting is really, yeah, it's kind of choppy and pulsing, so I'm not sure if that's from my power supply. I'll test this again when we hook up the batteries, but it almost looks like it's being driven from a PWM signal, so it actually might be. The output of this board is most likely PWM to drive that motor, so I'm going to put a couple, probably 10 microfarad capacitors in the output of this board here. That's PWM for you. Okay, cool. Looks good to me. And plug in the battery. Flip the switch. Ow, jeez, that's bright. I found a really easy way to fix that flickering problem. I just took a 10 microfarad 25 volt capacitor and I'm going to solder it onto the output of the servo board, and I'll give you a demonstration. That's without the capacitor, and then with the capacitor on the output, smooth lighting. So I'm going to go ahead and solder that and mount everything up. Everything's all mounted up and works great. Here's a quick test once more. No flickering because we added the capacitor. Switching really quickly and absolutely no problems. The MOSFET does get a little bit warm, but that's after a few minutes of operation, so I'm not really worried about that at all. And we have to kind of be cognizant about the battery voltage not dropping too low because we have no way of monitoring that, but it draws, right now we're only drawing about 3/4 of an amp, so it shouldn't drop too fast. And now I'm just going to wait till it gets dark and we'll do some cool night flying tests with it.